Can you hear me?
You sure can. And hello,
Okay.
welcome to the American Rocketry Challenge Ask an Engineer webinar. My name is Richard. I'll be in the background answering any WebEx technical questions. If you experience any technical troubles at any time during this WebEx event, please type your technical issue in the Q&A panel, and I'll be able to help. You are part of a larger group of listeners today, but is not shown for privacy reasons. All of today's attendees will be muted for the duration of the presentation. Also, this call is being recorded. We will be holding question and answer sessions throughout today's event. You may ask a question at any time throughout the event by entering it into the Q&A panel, which you will find at the bottom right of your screen. I'd like to introduce you to your first speaker for today, Jeremy Davis. Jeremy, you have the floor.
Thanks, Richard. Thanks, and welcome everyone to our first Ask an Engineer webinar for the 2020 American Rocketry Challenge. We're really thrilled to have so many of you all here, and thanks again to everyone who asked questions ahead of time. We'll look forward to getting to those. But without any further ado, I'll go ahead and introduce our engineer panelists for the day, and we'll start off with Don McMonagle.
Hello, my pleasure. And Jeremy, are you looking for me to give you a little summary of my background here?
Yeah, if you all wouldn't mind just talking a bit about the work you do and have done and your backgrounds, please.
Okay. I'm pleased to be on this webinar because it's talking about my favorite subjects, engineering and spaceflight. And I will tell you that during my career, I was fortunate enough to have flown 3 space shuttle missions on 3 of the different space shuttle vehicles. And I was doing that in the era where we were starting to plan the assembly of the International Space Station. So it was an exciting time for me. And today I work for a joint venture company called Range Generation Next, which is a joint venture of Raytheon Technologies. And we conduct space launch ranges, instrumentation management for the ranges to launch several rocket types to include Minuteman ICBMs and ground-based defense interceptors and commercial launches of the Atlas V, Delta IV, and Falcon 9 rockets. As part of that job, we launch weather balloons, we measure electrical fields to make sure that there's no potential for lightning strikes. We manage surveillance radars that make sure that there are no boats or airplanes in the trajectory of the vehicles. We also manage the reception of telemetry signals from the rockets and their payloads to make sure the rockets are performing well for the providers of the rockets and to ensure that their payloads are healthy. I will say that Raytheon participated early in the spaceflight programs with the development, design, and testing of the Apollo guidance computer that navigated us to the moon and back in the Apollo era. That computer in the 1960s had a massive computing power of 2 kilobytes internal memory. Once we were on the moon, it was Raytheon's transmitter tube that enabled us to send voice and video back of the Neil Armstrong taking the first steps onto the moon. Raytheon continues to participate in the space technology with management of spacewalk training in a neutral buoyancy laboratory at Johnson Space Center. We manage the spacesuits and equipment and tools that do that work. And we are working on how to manage thousands of objects that are tracked in space and keeping track of their trajectories. But I will say throughout my career, I've seen a lot of engineering challenges surface, and I've seen some of the best government and industry engineering teams resolve those challenges. And it's my pleasure to be here on this webinar to answer your questions and discuss how these teams use fundamental engineering principles to resolve problems and achieve incredible objectives. So I'm looking forward to this discussion. Thanks.
Thanks, Don. And now I'll turn it over to Helmut Bevensee from Aerojet Rocketdyne. Helmut?
All right, well, thank you for having me. I'm excited to be here, and I'll give you a bit of a background about me. I don't have quite the extensive experience that my fellow panelists here do, but I'll start with my educational background. So I went to Salisbury University in Maryland and also University of Maryland College Park to get my bachelor's degrees in physics and mechanical engineering. And then I went on to pursue a master's degree in mechanical engineering at the University of Maryland, where I focused heavily on life cycle engineering, related to reliability. And it was actually, it was a mechanical engineering degree that focused heavily on electronics reliability that got me a job, at Aerojet Rocketdyne working on rocket engines. So it's funny how things work out. I would not have expected that when I started my undergrad career. At Aerojet Rocketdyne, I'm now the one of the managers for the Reliability, System Safety, and Specialty Engineering group. We work largely during the design and development phase of programs to ensure that we are designing products that are going to be reliable and safe. Especially when they're carrying astronauts to space and other cargo. The kind of things that we look at in our department, we focus on the physics of failure of systems, of our largely propulsion systems. By understanding the physics of how things can degrade and fail, we can then work to prevent those things from occurring and optimizing the reliability of our designs. So we use a broad, understanding of engineering principles and physics. We also use probability and statistics for some of the modeling, where we will, predict the failure probability of systems throughout their whole life cycle. So that's in a nutshell part of what we do in our department. Now at Aerojet Rocketdyne, we're involved in a pretty broad suite of products, largely in the propulsion field. So we provide everything from the small, tiny thrusters that can go on like a reaction control system for in-space propulsion. We work on electric propulsion for in-space, but we also work on power systems, like the power system on the International Space Station. The new lithium-ion batteries, we're part of that. We also work on the radioisotope thermoelectric generators that go on, high visibility programs like the Mars rovers. And then we also have a broad history and experience on large liquid fuel engines, like going all the way back to the Apollo era. We worked on the F1 engines out of the Canoga Park facility here in LA, California. And also, right now working on the RS-25 engines that are going to power the first stage of the Space Launch System that will be taking humans back to the moon, within the next few years. And so that, I guess I'm focusing there on the site that I work at in California, but we also have the Rl10 engine is one of the popular products that comes out of our West Palm Beach site in Florida. And that has a very extensive flight history going back, I think going back to the Voyager spacecraft, the Rl10 engine was used at that point. So going back quite a while. That's in a nutshell what we do at Aerojet Rocketdyne.
Thanks so much, Helmut. Lots of engine history there. And then we'll turn it over to our last but not least, Jim Steenson. Jim?
Well, good afternoon, everybody. And it is definitely a pleasure to get the opportunity to chat with you folks, and I'm looking forward to that. I'll start off by just kind of telling you a little bit about my path to becoming an engineer, and then I'll tell you a little bit about my engineering career itself. And basically, as long back as I can remember, I've been interested in rockets and airplanes and things of the like. I remember I was only 6 years old when Apollo 11 landed on the moon, but I remember being riveted to the television to watch that landing. And then when Neil Armstrong took his first steps, it was late at night. It was, in the wee hours of the morning, I think. And I made my mother get me up to watch that. So that was neat. And then about a year later, when I was only 7 or so, I went for a ride in a little airplane, and I've been hooked on that ever since as well. Somewhere along the way, I really wanted to understand how things work, so I started taking things apart at home. So that went over really well with my parents. I remember one time my father told the story of he sat down in the living room to read a book, and the lamp wouldn't work. And he looked down and saw that the electrical cord had been removed from the lamp. And I don't really remember exactly what I needed that electrical cord for, but I'm sure it was very important. But at any rate, I learned by basically, initially anyway, by taking things apart and putting my hands on things and understanding how they worked and why they were done the way they were done, and different materials, metals and plastics and electronics and things like that. And I found that I could actually do quite a bit of learning on my own with electronics, because it was a thing that you didn't need fancy saws or machines or anything like that. You needed a $5 soldering iron and off you go. Eventually, I made my way to the University of New Hampshire and studied electrical engineering there, and had a very good and very rewarding career there. One of the things I can say that was a challenge there was I wanted to really excel at being an electrical engineer. So I ended up taking on some extra projects and things like that in schools, and I think that was something that really went a long way for me as well, because it made me think about the process of planning a project, planning a design of a thing. It can be anything you want, a mechanical thing, a toaster, a rocket to take you to the moon, whatever it is. But there's a process. You start with a set of requirements and you work your way through that. And I've been able to apply that pretty well in my career. I went to work at various companies, but it was one small company, and then they got bought by a bigger one, and then by a bigger one and a bigger one, and it's all essentially led to the same company that I'm at now, which is BAE Systems. I started my career as an electrical engineer back in the late 1980s, and I got to work on first thing I got to work on was a satellite, a NASA satellite called the Upper Atmosphere Research Satellite, the URs. And I got to work on one of the instruments there and work on finishing up the development and the testing. And that was just absolutely just exciting beyond belief for me, because I was interested in those things. But I was just so delighted that I could actually get to go work on it. I then got to work on another NASA spacecraft called SOHO. We developed a control system for that. And that was one of the most challenging things I've ever worked on. The technology involved was amazing. And then I got to actually work on a balancing wheelchair that was the forerunner. It was the same company and the same technology that turned into Segway. So at the same time, all of that started by trying to balance a wheelchair. And then probably pushing 20 years ago, I got involved in this the laser-guided supersonic rocket that we work on for the military, and I've been launching rockets in various places around the world, in Australia and things like that, ever since. And I've had the privilege of starting off doing the electronics, and now I'm a system engineer, and I do guidance and control development and everything else under the sun. So that's about it for me, and welcome to everybody, and I'm very glad to be here.
Thanks so much, Jim. And now we'll open up to questions. We're going to start with questions that we got from students ahead of time. And a reminder that only panelists can see the questions that you submit in the Q&A box. And when you submit your questions, please make sure you say the school or organization you're from. And we're going to prioritize the questions that we get from students first. So to open up, we got some variation of this question from a lot of our seniors this year. And we went through and tried to really get at what the core meaning of it is. And what we heard a lot was, how do you handle major setbacks in pursuing big goals, like becoming an engineer or an astronaut? And then maybe talk about some of the setbacks that you faced and, how did you overcome them? And this is for all of you.
Well, I'll start by saying that when I was in high school, much of what Jim just described as desire to tear things apart and be an engineer and a desire to fly were the two things that led me to select the Air Force Academy as my college of education. However, when I applied to the Air Force Academy and stated in my medical summary that I had had allergies as a child, that disqualified me from being a pilot or doing any flying, which by contrast of my career, having flown up to 260 miles above the earth, that was a little different than the constraint I had going to the Air Force. So my encouragement to you is look at the details of the constraint you have and look at all the alternatives that you may have to address the issue. What I found in my sophomore year at the Air Force Academy was that there was a way to get a waiver for allergies. And for me, it meant taking some allergy sensitivity tests and then taking desensitization shots starting at 2 times per week and doing that for 5 years before I got a waiver to be qualified to be a pilot in the Air Force. And later, I had to get an aeronautical summary concerning allergies to be qualified to be accepted into the astronaut program. So look at the details, and you may be able to find an alternative path. To be able to be both a pilot and an engineer after I became an operational pilot in the Air Force, I found a way to get back into engineering because piloting by itself was technical, but it wasn't engineering. Going to test pilot school allowed me to get back into the engineering world in addition to continuing to fly. So look at alternatives, study the details. And if you don't, no one will do it for you. That's my message.
I can second that. That's a really good point, Don. That what I found is when we run into a setback or some adversity or some challenge, sometimes there are things that are out of our control. Sometimes there are things that we may be able to influence in the first place, but nonetheless, you find yourself in a situation where there's a problem to be solved, but you need to move forward and you do something about that. And my advice is just in a situation like that, what I do is you have to kind of hunker down and stay very focused on what the end goal is, what you're trying to achieve. And as Don said, you look at all the different alternatives and you think about different ways that you might solve the problem and try to think outside the box. Just, nothing's off the table. Just sky's the limit and think outside the box and stay focused and be tenacious about it. Because when you decide that that's what you want to do, like it sounds like Don decided he wanted to fly. And oops, he had allergies, and so the Air Force was going to tell him he couldn't fly, but he found a way. But he was tenacious about it. He grabbed onto it, and he would not let go, and he did not give up until he met that goal. That would be the advice I give as well. That's really what you've got to do when you're in that situation.
Yeah, and some of the advice I would offer, some of the challenges I had in the path to my career was actually involved with, it was related to the fact that I immigrated into the U.S. and around the time I was going into college, I was still considered an immigrant, and I didn't have permanent residence here in the U.S. yet, going through all that process. So there was actually a lot of uncertainty in the future about whether I'd be able to have a career in aerospace, because that can be a limiting factor with certain jobs, especially the work I do now that can be defense related. I wouldn't be able to do that unless I was a U.S. person or citizen. So I had some challenges related to being able to find internships at the time. where I just couldn't qualify and whatnot. But what that ended up presenting was a number of new opportunities for me to kind of make the best of the situation. So, for example, I couldn't get into my school of choice because of that limitation, and so I ended up taking a bit longer path to finishing up my undergraduate degree. It took me 5 years instead of 4, but at the same time, I ended up being able to get a double major. And so I was able to get that physics background that really, has strengthened my engineering skills. And then, as I was getting towards the end of my undergrad career, I had to come to the decision of whether I was going to go on to grad school or go into industry. Well, at the time, I still wasn't a naturalized citizen yet, so I couldn't get the jobs like at Aerojet Rocketdyne that I really wanted. So I took that as an opportunity to say, well, what better excuse than not only am I going to further my career with my master's degree, but hopefully by the time I'm done with that, I can actually apply to this job that I was eyeing and qualify for it. So when these hurdles have come up, I'd like to look at the opportunities that they may present, and the end goal was always the same for me. I've always been fascinated with flight and working on in aerospace, but I had to take maybe a less direct path to that. But at the end of the day, I feel like all those deviations that I might have taken from my original path gave me the exact background and experience that ended up making me a perfect match, for the position that I have now, working on rocket engines. So I'd say, be open to opportunities and, persist. If you have your end goal, work towards that. But look for the opportunities that challenges can sometimes provide, the hidden opportunities.
Oh, that's great advice from all of you, and thanks so much. And speaking about studying and finding the right path there, we'll go to our next question from the Lincoln Rocketry team at Lincoln High School. And they ask, what did you find most challenging about going from studying engineering in the classroom to working and being an engineer in the real world? Helmut, you want to start us off again? Oh, looks like we've got some technical issues.
Here we go. You can hear me now?
Yes, we're all good.
That's my redundant mute button there. So the question is regarding challenges going from studying engineering to being an engineer in the real world, right?
Yes.
So to me, the biggest challenge was I felt like I had a really good technical background from the University of Maryland as far as the science and the physics background that I need to understand the engineering principles. I felt very comfortable coming out of school with. The one thing that at the beginning I felt like I was maybe drinking from a fire hose was getting used to the very structured systems engineering approach that is needed when we're doing, working on systems as complex as, the propulsion systems that we work on. So there are a lot of acronyms that I had no idea what they meant. Very structured, design milestones that we follow that I had to kind of learn on the job a little bit and just getting brought up to speed and all that. Like I said, in general, I felt very prepared with the technical side of things and the actual design development process, working in a very large team of engineers where teamwork is key was the new challenge.
Any of the rest of you want to hop in with your experiences?
Sure, I'll make a comment. There was a couple of things that I think that was a really great question, by the way, and there's a couple of things came to mind to me. One is when you transition from the school, the academia, into industry, and you start doing real engineering work, that's when you start to realize how little you know about engineering and how things actually do work. And I felt very comfortable and prepared, just like Helmut did. But you get there and you start to realize, oh boy, I guess I still have a whole lot to learn. And I will tell you that I learned something new about the guided rocket that I work on, that I've been working on for 19 years. And I learn something new about it every day. So you will never stop learning. You want to keep absorbing that and finding new factors. Another thing I found that was very different was when you start to become an engineer, and initially, you're working with mentors and peers and other people working on a team, but eventually what starts to happen is others are starting to make decisions, business decisions, program decisions, other engineering decisions based on your answers. So getting the right answer is not about getting an A or a B or a C anymore. It's about whether or not this thing is going to actually work. And that's really important. That was something I found too. And the other thing one of the things I found that I really liked was after a few years and you start to dig into some really neat things, you start doing things that no one really has done before. And it might be developing a new piece of technology or looking at a problem, solving a problem a different way, or solving a completely new problem. But when you start to do that, the challenge there is that you have to come up with your own ways of testing to see if you got the right answer. So you have to develop tests, and whether they're physical tests or mathematical tests or things like that. There's a lot of evolution that goes into what you learn from school. So school is really important. It gets you the basics, though, just the basics. You're going to learn so much more when you get out.
This is Don. I'll just add, I agree with Helmut and Jim's assessment there. I would put it in the context of risk. When you're in an academic environment, you're not taking physical safety risk, you're not taking cost risk. And when you get to the real world, there are consequences to mistakes. And that's what the real world holds you accountable to, rather than a grade. It holds you accountable to whether you're putting somebody or something at risk, and whether you're putting your company's finance at risk.
Yep.
No, absolutely insightful there. And we've got our next question, continuing with education, and something that I'm sure is on the minds of a lot of our students right now, from Kyle at Madison West High School. And he asks, how important are undergraduate activities and programs in showing an aerospace employer that you would be a good fit? Is it worth, say, spending more on an undergraduate education that might have better or more relevant activities and extracurricular opportunities?
I'll weigh in on that. I would say that specific undergraduate, aerospace-related undergraduate activities, they definitely help. I do a lot of interviewing of young engineers at BAE, and I have found that we do look at the types of projects and curriculum, not only, but the extras. The extras, they do help, but as important, if not more important, we look at whether or not the engineering candidate, the student, has learned. Do they have a good technical aptitude? Yes, of course we want people who have a pretty good solid understanding of their math and the physics and things like that. But it's important to find out, have they learned how to learn? Because what you learn in school is this big. It's this tiny little piece of what you're going to learn in your career as an engineer. So the more important thing is to make sure that you learn how to learn. And so that's one of the things that we look at. And that may or may not really mean that you've done something in the aerospaces or something like that. We want to see that you can problem solve, and we want to see how you would approach a problem. And again, it's nice if you've done something. We had a candidate recently who built his own drone from scratch, and built the whole thing, and he designed the autopilot, and it ran on an Arduino kind of thing. And that was great. I mean, that showed us that he had a very diverse set of skills. The fact that it was related to an aerospace thing is great, but it wasn't absolutely necessary. And I'll speak for myself. When I entered my job as the first thing I got to work on was a NASA scientific satellite. I really hadn't had any aerospace specific projects or training in school. I had a decent electronics background. I did have a pilot's license at that point. I got my pilot's license and instrument rating when I was in college. But other than that, that was it. I had worked summer jobs writing computer programs for a retail company, but nothing really with aerospace. But I was able to get right into it. So it helps to do those things, but I don't think it's absolutely necessary that you have a huge aerospace resume before you go get your first job.
I'll add just a simple formula to that. Having been on selection review boards for astronauts and in a management role in industry, I will tell you the first thing I look for is what's the area of education? Is it applicable to what job I need you to perform? Then what's the quality of the education? And that judgment is just a hurdle to get through to getting to what has been the demonstrated performance in your field of expertise. And then a very important part of this is what is your character and your ability to work with others on a team. Because when I'm interviewing somebody, I'm looking for whether or not they are an individual player or a team player. Because rarely do engineers accomplish major things in isolation. They work as teams to accomplish major objectives. And then I'm looking for, in terms of character type, do you have a diversity of your background? Are you involved in clubs? Are you involved in extracurricular activities? Have you gotten a pilot's license if it's applicable to your job in terms of experience? Those kinds of things weigh in as tiebreakers as to whether you're a diverse individual with your experience base.
And I'll add a little bit to that as well. So I think that those are excellent points that Jim Don made. I'm in what's considered a specialty engineering discipline. So not a lot of schools have undergraduate, even electives in reliability or system safety. So for the specialty discipline, one of the things I definitely look for is if somebody has the educational experience, statistics, probability courses, that helps a lot in what we do. And we also look, if somebody has specific electives that are related to things like reliability, life cycle engineering, that can help set somebody apart because it is such a specialty discipline. I would think, if you're going in to interview for something like a structural analyst or a designer, depending on the type of engineering degree that you have, many of the applicants will have the basic requirements to do that job, and that's where extracurriculars could help set you apart. Typically though, if you find electives and things that you're interested in, then they can help set you apart if you put that in your resume and tailor that resume to the job that you're applying for.
Thanks, gentlemen. And now we'll turn to a question we've got from the audience. Imad Rana asks, could you explain a bit about the roles of aeronautical engineers and what they do? They're specifically interested in becoming an aeronautical engineer. So I guess talk a little bit about how specifically aeronautical engineering is different than, say, mechanical or structural or just systems.
Well, let me tell you my experience mainly with aeronautical engineers was in the flight test community while I was a test pilot at Edwards Air Force Base. And the aeronautical engineers had some tremendous challenging work in first defining what maneuvers to put our test vehicles through So they wrote the test card and said, go up and achieve these speeds, these turn radiuses, these bank angles, these combinations of control inputs. And I would go execute the aeronautical engineer's plan in flight. And after we got the data back from the recorders and the telemetry that were sent to the ground, then the aeronautical engineers would go back and review whether or not their expectations of how the airplane would react under those flight control conditions was matching what they predicted, and make corrections to that and set up the card for the next day in order to certify the airplane for its flight envelope. Aeronautical engineers are what I feel has to have a broader perspective on other engineering fields to understand the implications for the mechanical stress and strain that goes through the airplane that mechanical engineers would take. They have to understand the control systems that electrical engineers would understand and computer science engineers would understand about how to set up the closed loop control systems in the airplane. But the aero engineers is looking at the aeronautical response of the airplane to the overall, and in execution of flight tests, they needed to understand all the other engineering disciplines. So it was a good generic field.
All right. Well, go ahead, Jim.
No, I was just going to add a little tidbit about the aeronautical engineers that I work with on the laser-guided rocket. They do a lot of sounds very similar to what Don's experience was, but they do a lot of analysis work, fluid dynamics work. We also spend a lot of time in the wind tunnel with the model, trying to understand exactly what's going on, and that starts to formulate our expectations. And now on the guided rocket I worked on, that it's only about 2 3/4 inch diameter, there isn't room for Don to get on board and fly it through the test card for that day. So we do what we call control test vehicle, or CTV test flights. We do that same thing. We have a computer program that basically executes the commands that we would have Don do if he would fit. But they're looking at the aero loads, the Mach effects, the importance of consideration of dynamic pressure, Q, things like that. So it's just very similar kinds of things, I think, that Don's experienced, but we just do it at a different level.
Yeah, Jim, let me add that I couldn't agree with you more that having a human fit in the airplane is a constraint. And I will tell you that some of the flight testing I did, I was convinced should have been done with a remotely piloted vehicle, because the human physiology becomes the constraint in the flight test. And the aeronautical engineers have to conduct everything, including the piloting function, while they're flying the unmanned vehicle. And I think generically in technology, we're headed more and more toward unmanned vehicles performing more and more of the transport functions, reconnaissance functions, et cetera. Humans are not going to be as much in the loop as they've been in the past.
I agree.
So all the more importance for a good aeronautical engineer. I think you've got a good future there, Ahmad. Our next question, similar vein, from Molly, Knox County, Ohio, 4H. How did you figure out what type of engineering that you wanted to focus on? Helmut, you want to chime in to start us?
Yep. So how did I figure out what type of engineering? That's an interesting one, because I'm one of those people that, I become interested in everything, and I want to learn everything. I think a lot of engineers are probably like that, and there's only so much time in our lifespan to learn only so much. But because I wanted to have the ability to work on a broad set of projects, I looked at my father, who's a mechanical engineer, and I looked at his career, and I saw how he had been involved in all different types of industries doing different work, largely in automation. But that gave me the sense that mechanical engineering was a good choice for me to follow, where it would give me the flexibility to kind of decide where I wanted to end up going. So, once I started along that path, I did use the availability of electives and different activities to my advantage so that I could learn more about different topics until I found one that I thought was a good fit. So I took an elective that was, related to the life cycle of electronics specifically, but it looked at the physics of how things fail. And that really got my interest. And at the same time, I was also interested in just, gadgets and whatnot and figuring out how they work. I remember as a kid, I used to build Legos, and what I would do is I would build like a tank and smash it against the wall and see where it failed, and then go back and redesign it so that it wouldn't fail. And so, that kind of was part of what made me realize that I was interested in preventing failures, and that's how I ended up doing what I'm doing now.
I got to tell you, my approach wasn't so methodical. When I was entering college, we were in the middle of the Apollo program, and the idea that space was popular led me to astronautics. And when I got to the Air Force Academy, I asked, what is the toughest major to take? And they said it was astronautical engineering. So I said, I'm in. I want to do the toughest one I can. So there was no science involved in my selection.
I think for me, it's kind of just it grew out of my my disassembling of things and seeing how they worked and what I had learned how to either fix or design new circuits and do different kinds of things. I was interested in music also as a kid, and so my friends, of course, we needed to make our electric guitar amplifiers louder and things like that. So I learned how to build better amplifiers and things. So for me, I think it was just an extension or progression of what I had gotten my hands dirty with as a kid.
Helmut and Jim had done all along. Meanwhile, Don just wanted to go for the hardest thing you could throw at him. We've got time for one more question from Anastasia, from the South Chinese SCCA. What is your proudest project that you've done in your career? A little bit of a tough one, but I think a good one to close on. If you can talk about what it is that you're the proudest about.
So I can start that off. Since my time at Aerojet Rocketdyne, I've been involved with. I've almost lost track of count of how many different projects I've been involved with. And then, surprisingly, the thing that I'm the most proud of right now is while I'm still doing technical work and supporting specific programs, I'm also leading a team of engineers they're largely working on the Rl10 engine that's going to power the Space Launch System. And my team is doing, a lot of the work, but it's such an honor to work with, the experience that they have, the lessons learned that they've carried over the years, and it's inspiring to watch them work, and that's probably the proudest thing, so far in my career. And just being able to learn from them. Recently, one gentleman in my group retired a couple weeks ago, but he actually started at Heritage Rocketdyne, and I think it was 65. So he was working the Apollo program when we landed on the moon. And, just hearing the stories directly from him about, how it was back then to work on the F1 engines and the development for that is, that's so far, some of the coolest, experience I've had.
I would say that is a very hard question, actually, to especially to narrow it down to one. I've had the very good fortune that I've gotten to work on a lot of really neat things. The two scientific satellites that I got to work on were just fantastic opportunities with URs. It allowed us. It was the key spacecraft that got us an enormous amount of information to understand what was happening with the ozone. And I know, we know so much more today because of the work that we did with yours. We're learning more about the sun with SOHO. That was extremely rewarding and got a lot of pride with that. But I would also say that the program that I'm working on now, the guided rocket, is also something that gives me a lot of pride because it ensures that the men and women who put themselves in harm's way to protect our freedoms have the best tools that they have and that we can make with them. That's really good too.
Now, I agree with Jim. It's really hard to pick one thing to say that's the one thing that I'm most proud of that I was a participant in. And I want to emphasize participant because what I'm about to characterize as one of my best accomplishments as a team couldn't have happened without Helmut's company getting me into space and couldn't have happened without Jim's UR's program. Because on my last mission as a space shuttle commander, my team on orbit and the thousands of people on the ground that managed this atmospheric laboratory for applications in science, we were able in the space shuttle to catalog 80% of the globe's middle atmospheric chemistry. And in doing so, help the scientists that do global modeling of ozone depletion and recovery understand the model and put protocols in place that would help the ozone replenish itself. They also were able from that data to determine why the Antarctica ozone hole is created every year and why it is recovered every year. And that in concert with yours and other sensors in space and the ability to get to space because of rocket propulsion, this whole team, all of us on this panel, cooperated in making that an objective that I'm very proud of.
And something to definitely still be proud of as we've made some great recovery with the ozone hole as well. So that's all the time we've had. We've gone a little bit over. I'd like to thank again our fabulous panelists, Don, Helmut, and Jim. And thanks to everyone who sent in so many questions. We've got plenty more that we didn't get to. And like I said at the start, we hope this to be a start of a series. So we hope you'll stay tuned and continue to listen on more for future panels. Thanks, everyone.
Bye-bye.